Imagine you're an explorer on a quest to unlock the secrets of the human mind. But what if I told you that AI is doing the same thing? Welcome to Neural Networks Explained Simply, where we journey through how machines learn to think just like us. Picture this: your brain is a vast network of billions of neurons, firing signals to help you decide what to eat for dinner or recognize a friend's face. Now, AI's neural networks mimic that magic. They're not sci-fi robots taking over, they're clever systems inspired by biology, powering everything from Netflix recommendations to self-driving cars. In the next few minutes, we'll strip away the complexity and reveal how these digital brains work. Stick around as our explorer uncovers the first layer of this fascinating world. Get ready to see AI in a whole new light. Let's start at the basics. Think of your brain's neurons as tiny messengers. When you see a cat, one neuron spots the whiskers, another the fur, and they team up to yell, "Cat!" Neural networks in AI work the same way, but with math instead of biology. Each neuron is a simple calculator that takes inputs, like pixels in a photo, and multiplies them by weights, adds a bias, and decides if it should fire. It's like a party where guests' inputs vote based on how much they like the host weights. Our explorer is now in the heart of this neural party, watching connections form. But how do these neurons organize? That's where layers come in, building the foundation for smarter AI. As we dive deeper, you'll see why this structure is key to AI's learning power. Excited? Let's layer it up. Now picture a neural network as a skyscraper. At the ground floor, the input layer gathers raw data, say, numbers representing an image's colors and shapes. These pass up to hidden layers in the middle where the real magic happens. Each layer processes info, refining it like a chef tweaking a recipe. Finally, the output layer delivers the verdict. This is a cat. Just like how your brain filters sights and sounds to understand the world, these layers help AI make sense of chaos. Our explorer reaches the first hidden layer, feeling the buzz of computations. But networks aren't born smart, they learn through trial and error. Up next, we'll explore how training turns a blank slate into a genius. It's like teaching a kid to ride a bike, wobbly at first but rewarding. Keep exploring with me. Training a neural network is like training your puppy to sit. You show it examples, good ones and bad ones, and reward correct guesses. In AI terms, we feed the network tons of labeled data like photos tagged dog or not dog. It makes a prediction, compares it to the truth, and calculates the error. Then, using an algorithm called backpropagation, it tweaks those weights backward through the layers to minimize mistakes. Imagine adjusting dials on a radio until the static clears. Our explorer sees the network stumbling at first, outputs all wrong, but with each iteration it sharpens. This process, called gradient descent, is the hill climbing that pulls AI toward perfection. It's not instant. It takes computing power, but that's why your phone's face unlock gets better over time. Feeling the learning curve? Next, we'll see how deep these networks go for superhuman smarts. Enter deep learning. The deep part means more hidden layers, like going from a single-story house to a towering apartment complex. Each added layer captures more abstract features. First layer spots edges, next shapes, deeper ones recognize full objects. It's why AI can now beat humans at chess or diagnose diseases from X-rays. But more layers mean more complexity. We need tricks like activation functions. Think RayLU, which acts like a light switch, turning neurons on only if the signal is strong enough. Our explorer descends into this depth, marveling at how simple math stacks up to profound intelligence. Relate it to your social media feed. Algorithms use these networks to guess what videos you'll love. The deeper, the more personalized. But what happens when it all connects? Coming up, the power of forward passes and real-world wins. Once trained, a neural network runs a forward pass. Data zips from input to output in milliseconds, making predictions faster than you can blink. It's like a well-oiled machine in a factory churning out decisions. Activation functions add nuance, sigmoid for probabilities between 0 and 1, perfect for yes or no questions like spam detection in your email. Our explorer rides this wave, feeling the seamless flow that powers chatbots like me, helping you navigate life. But it's not perfect. Overfitting is a pitfall where the network memorizes training data but flops on new stuff, like cramming for a test without understanding. We fight it with dropout techniques, randomly ignoring some neurons during training. This keeps things generalizable. As we build to the climax, imagine the applications exploding from art generation to climate modeling. The journey's heating up. Backpropagation isn't just tweaking, it's the feedback loop that makes AI evolve. Errors propagate backward, adjusting weights to nudge the network closer to truth. Think of it as a city's traffic system learning from jams to optimize flow. Neural nets do that with data highways. In practice, tools like TensorFlow make this accessible even for hobbyists. Our Explorer fixes a jam in the network watching efficiency soar. Now consider convolutions for images. Special layers that scan like eyes, spotting patterns efficiently. This is why Instagram filters or medical scans are so spot on. But ethics peak-in bias in training data can lead to unfair AI, like facial recognition failing on diverse skin tones. We're learning to train responsibly. Deeper we go toward insights that will blow your mind. What's the real power here? Stay tuned. For sequences like speech or stock prices, recurrent neural networks RNNs add memory, looping info back to remember context. Think predicting the next word in a sentence. LSTMs improve this, handling long-term dependencies without forgetting the plot. Our Explorer hears echoes of past decisions shaping the future, just as AI forecasts weather or your next Amazon buy. Transformers, the latest stars behind GPT models, use attention mechanisms to weigh important parts, revolutionizing language AI. It's like having a spotlight on key story elements. This deep dive shows how layers stack to superintelligence. But the climax awaits, how neural nets are changing everything from healthcare to creativity. Feel the excitement building? We're almost at the peak of this neural adventure. Here's the insight that ties it all. Neural networks aren't just tech, they're bridges to solving humanity's toughest problems. In medicine, they analyze scans to catch cancer early, saving lives with precision your doctor dreams of. Self-driving cars use them to see the road like superhuman eyes, reducing accidents. Even creativity blooms, AI generates music or art, inspiring creators like you. Our Explorer stands atop the skyscraper, gazing at a world transformed. Personalized education adapting to your pace, environmental models fighting climate change. But power demands responsibility. We must ensure fair, transparent AI. This is the heart of neural networks mimicking brains to augment ours. Mind blown yet? As we peak, reflect on how this tech is already in your pocket, shaping tomorrow. The revelation continues. The true power shines in real impacts. Take AlphaGo beating a Go champion not by brute force but by intuitive play, thanks to deep reinforcement learning, where AI plays millions of games against itself. Or how networks power voice assistants, understanding accents to feel more human. Yet challenges like the black box problem persist. Why does AI decide X? Explainable AI is emerging to demystify. Our Explorer convenes with global minds, weaving ethics into the network. For you 20-somethings navigating careers, this means jobs in AI ethics or development are booming. It's empowering, not scary. These insights reveal neural nets as tools for good, evolving with us. As the story crescendos, ponder your role in this AI era. Almost home, let's wrap with takeaways that stick. Key insight: neural networks thrive on collaboration. Hybrid systems pair AI's speed with human intuition, like doctors using AI suggestions to focus on patients. This symbiosis could eradicate poverty through predictive aid or accelerate discoveries in science. But it calls for diverse data to avoid biases. Your voice matters in training tomorrow's AI. Our Explorer partners with the network, creating harmony. Emotionally, it's thrilling. AI as an ally, not adversary, amplifying our potential. For your generation, it's a call to learn, innovate, and guide AI ethically. We've journeyed from basics to breakthroughs, hearts racing with possibility. Now, as we conclude, carry these sparks. AI learns like us, layer by layer, ready to light your path. Final stop: takeaways in your next step. We've traversed the neural landscape, from puppy training analogies to world-changing apps. Takeaways: neural networks are brain-inspired layers learning through tweaks and data. They're in your daily tech, promising a brighter future if we steer wisely. Start small, try free tools like Google Colab to build your first network. It's accessible and fun. Thanks for joining this adventure on AI Explained Simply. If it sparked curiosity, hit like, subscribe for more demystified AI, and comment. What's your burning AI question? Share with friends who need this clarity. Remember, you're part of the AI story now. Until next time, keep exploring, keep learning, and let's build an amazing tomorrow together. Fade out with a neural sparkle.